Lesson 11.3, Analyzing Geometric Sequences and Series. To review, an arithmetic sequence is adding to get the next term. A geometric sequence is multiplying to get the next term, multiplying by a common ratio, which we'll call R for ratio. So, is this geometric? Well, let's see. This is times 2. That's times 3. That's times 4. And that's times 5. Is that the same thing? No. It's not geometric. Let's try this one. Well, this one's a little hard to figure out what we're multiplying by. So let's just go 48 divided by 96 is a half. Oh, what do you know? 24 divided by 48 is a half. 12 divided by 24 is a half. 6 divided by 12 is a half. So each time we're multiplying by a half. So yes, and R is 1/2. The formula for the nth term of a geometric sequence is an equals a1 times r raised to the n minus 1. Notice the variable is there and the exponent therefore is exponential. So, arithmetic was linear, geometric is exponential. Remember that. That'll help you on your test when you need to figure these things out, and you can just look and see, oh, it's arithmetic. And it's you're trying to do a sum. Or if it's exponential trying to do a sum, then it's geometric. Write the rule for the nth term and find A8. Okay? So an equals a1r to the n minus 1. Well, a1's easy. It's a 5. What's the r? Well, it'll just be 2 over 5. 0.8 over 2 is the same thing as, what, 0.4? Well, 2 over 5 is 0.4 also. So our r is 0.4 or 2/5. So there's our rule. It's nice, you don't have to simplify. In fact, you cannot multiply the 5 times the 2/5 because the 2/5 has the exponent and the 5 does not. All right, so now we want to know A8. So plug in an 8. And you'll probably just have to put that in your calculator. A8 turns out to be 0.008192 approximately. Why don't you pause this and try number 13. Let's find R. That's a half. That's a half. So R appears to be 1/2. All right, so it's an equals a1 r to the n minus 1. A1 appears to be 1/12. It's just your first term. R is 1/2. There you go. Can't multiply the numbers because the 1/2 has the exponent, the 1/12 does not. One term of a geometric sequence is A4 is 3 and R is 3. Write a rule for the nth term. Well, cool. For the nth term is an equals a1 r to the n minus 1. I don't know a1 though. But I do know that when n is 4, an is 3. So I can fill that in. R is 3. N is 4. This would be 3 cubed, which is 27. Divide by the 27, and we're going to reduce that to be 1 over 9. So, AN equals A1 times R to the n minus 1. Why don't you try number 23? You're done. You should have AN equals negative 3 for the n minus 1. If two terms of a geometric sequence are A2 equals negative 4 and AC equals negative 1024, write the rule for the nth term. Well, I don't know A1 and I don't know R. Okay, so AN equals A1 R to the n minus 1. So I can plug in this first one for n and AN. So I'll have negative 4 equals A1 times R to the 2 minus 1, where negative 4 equals A1 R to the first. The second equation, that would be N and AN, be negative 1024 A1 R to the 6 minus 1, negative 1024 equals A1 R to the fifth. All right, what we're going to do is we're going to solve this system of equations by substitution. So I'm going to take my first equation and I'm going to solve it for A. So we'll divide by R to get the A1. Can now take that and plug it in to the other equation. Multiply a fraction times a whole number. The whole number ends up on top. And I can simplify these. The R is the same as R to the first, and when I divide with the same base, you subtract. So 5 minus 1, subtract the exponents, is 4. Divide by the negative 4. And they'll have to fourth root. Now, when we fourth root, we should have plus and minus. Yes, it could be either. I think to be useful, let's just let it be the be simpler. Let's let it be the positive. 4th root of 256 is actually 4, so R is 4. So now I know R. I can take that and substitute it in there. So if negative 4 over R is A1. So A1 appears to be negative 1. So the formula is A1, or AN equals A1 times R to the n minus 1. Why don't you pause this and try number 35. Remember, the function is AN equals A1 R to the n minus 1. This is N and AN, N and AN. So you write two equations. The second equation, don't get scared because it has a fraction. It works the same way. Alright, take your first one and solve it for R. Sorry, not R, for A1. And substitute. A1 is negative 72 over R to the first. Simplify those. Divide by the negative 72. You get 1 over 1296. So fourth root, again, it should be plus and minus, but let's just make it positive for now. You get 1/6 for r. Plug that in there. A1 is negative 72 over r. You divide by a fraction by multiplying by its reciprocal. So A1 is negative 72 times 6, or negative 432. So your function is AN equals A1 times R to the n minus 1. All right, to find the sum of a geometric series, the formula is Sn equals A1 times 1 minus r to the n over 1 minus r. So why don't you find the sum of the first 10 terms? All right, it looks like the r is 1/2. 2 divided by 4, 1 divided by 2. And A1 is 4, so our sum, the first 10 terms, is A1, 1 minus r to the n is 10, because we want the first 10 terms for 1 minus r. Put that in your calculator. You get 0.99902 over 1/2 gives you 7.992. Or the fraction, if you do it in a fraction form, is 1023 over 128. Why don't you pause this and try this one? Number 44. If we compare this to AN equals A1, R to the n minus 1, you can see A1 is 5, R is 1/3, and the n is 8. So our sum of the first 8 is A1, which is 5, 1 minus r, which is 1/3, to the n for 1 minus r. Put in my calculator, I got 16400 over 2187, which is about 7.499. Let's say you tell the gospel to your friends. 4 of your friends tell the gospel to their friends, then 4 of each of their friends tells the gospel, and so on. Find the total number of people told the gospel to others after the 8th round. So it sounds like the R is 4, because it's each time it's 4 more. It's each of those is 4 more, so it's 4 times 4 times 4. And you're starting with talking to 4 people. So A1 is also 4. So the sum is A1, 1 minus r to the n over 1 minus r. We're doing 8 rounds, so n is 8. A1 is 4. R is 4. N is 8. R is 4. And I put that in my calculator and I get 87380 people have heard the gospel. That's a lot of people, just from you telling 4 people.